was part 1 of example 3, very similar to the last one we did, except that because it was less than or equal to, we ended up with the interval below 0, which was the one in the middle. I can come back and show this probably in another video later, perhaps, but just in case I don't get time to do that later, there it is. All right, here we are. Next one is another quadratic. So all we need to do is move this one to the other side. This one should go really fast. I'm just going to zoom through it. Factor, find zeros. So x minus 1 and x minus 1. This one's going to do what I was mentioning earlier. So what's the 0? There's only one 0. Now, so our number line is only going to have a 0 at 1, which means we're just going to have 2 intervals, negative infinity to 1 and 1 to infinity. Okay, let's go ahead and make our chart. So negative infinity to 1, not inclusive this time, so parentheses, and then 1 to infinity. Okay, we just need to test 2 numbers. 0 in the first one because it's less than 1, and 2 in the second one because it's greater than 1. Okay, let's plug those in. So 0 minus 1 times 0 minus 1 is a negative 1 times a negative 1, which is a positive 1. Right? And then 2 minus 1 is 1, and 2 minus 1 is 1, so it's 1 times 1, which is also positive 1. So these intervals, both at 0 and at 2, are positive. So what do we want it to be? We want it to be positive, and everything is positive except for 1 point. There's only 1 point where it's not positive, and it's 0. So if this were like equal to, it would be all real numbers, negative infinity and positive infinity. But because it's not equal to, it's just greater than, we actually have to split it up with our 2 intervals, with the union between them. Or another way we can say this in set notation is to just say x does not equal 1. And it equals everything else. That's a shorter way of saying that. But you should be familiar that either one works. So the graph for this one would just be sitting on the x-axis, everything's positive, and therefore the answers are everything but that point where it equals 0. Okay, now stopping my video, I'm going to go on to question 3. Gosh, all these are quadratics. We need to make sure we get to problem 4 just so you see one that's not a quadratic. So x squared minus 2x plus 1 is less than or equal to 0. I want to go through these though too because they're all kind of proving a point. So, what do you notice with this one? It's the same problem we just did, but with one difference. How is it different? So the less than, right? So we already know from the last problem, so we don't even have to do very much here. We already know that it's going to be positive on both sides and 0 in the middle. So the question is, where is it negative or equal to 0? Is it ever below 0? Never below 0, so there's nothing less than. There's only equal to 0. So this one, the answer or solution would simply be x equals 1. because that's the only thing that satisfies the inequality. Now I'm going to pose a different question to you on this one. What if it didn't have the equal sign? What if it was only less than? If it had been less than but not equal to, then nothing is below the x-axis. If there's nothing that fits it, then what does that mean? That means there's no solution, or that means that the set of solutions is empty. So sometimes we call that the empty sets. And when we call that the empty set, we can actually just use a 0 with a blank through it, like Ghostbusters or something. So no solution, which is also called the empty set. The set of solutions is empty. All right, stopping that video. And we can do number 4.